Let's talk about quick first who is FastRobot. First off, this is 3 techniques for promoting ChefRepo objects through CI techniques. So we're a small Unix consultancy. We've been doing this since 2009. System administrators long enough that we generally call this the system administration game rather than anything fancier. Technically, though, what we almost always do is integrate systems together. You never get the greenfield opportunity where you spec everything out at once. More often than not, you tiptoe through the brownfield of a bunch of legacy systems and processes. As the CI that you use to promote anything in your company is an extension of your company's policies, products, and pain points, we end up adapting this process to the client. So let's think about you guys, y'all. I think you value infrastructure as code. You think that everything that is electronic about your company and moves should be covered as code and should be in source control. You realize that if humans do the promotion and testing of things, humans mess up. So having processes do this for you is absolutely advantageous. You probably already have some familiarity with CI/CD. This would be a terrible place to start because I don't think I'll give you the right treatment of it. But I do at least want you to be familiar. Maybe you're just doing some apps. Maybe you know how to promote cookbooks that way already. Specifically, I hope you have a cookbook CI process. It lends itself pretty well to that, right? Cookbooks are versioned, they have an artifact, they produce an artifact, the tarball with the version number. So you looked around for how you can do ChefRepo promotions. There's not a lot of stuff on the internet. There's not a lot of prior examples of this. Plenty of good examples for cookbooks, so we're gonna try and cover that gap. What do I want you to have at the end of this? I want you to talk about all the things you could manage via a Git-based ChefRepo. And I'm going to define this so it's not so confusing. But more importantly, I want to know what you should manage via the API and via Git processes in ChefRepo. And of course, the wisdom to know the difference between the two. As we approached each of these clients and worked with them, we had a bunch of trade-offs we considered. We did a lot of false starts, and I wanted to kind of walk you through our thought process and what we ended up with and why. These are not all happy success stories. Some of them are, of course, terrible, tragic stories. But at the end, I'll give you some pointers and code examples for all the techniques we're talking about so you have something to start on should you try and do this yourself. So what if you just want to test and promote cookbooks only and you want to consider that half of the chef policy question? Great idea, wrong talk. There are lots of published solutions around this already. There's actually a parallel talk happening in the other room, so I can wait if you all want to leave. Chef Automate has a perfectly good solution around PR branches in GitHub, merge that down to a cookbook, run it through a bunch of tests and batteries, and promote it up to Artifactory or Supermarket. The chef themselves just released a new Jenkins plugin that does exactly that. It has a really nice UI, integrates well with Jenkins and Blue Ocean. It looks cool. And it's written in very traditional Maven-style plugin. The Hedge Ops, Michael Hedgespeth, I think, has an excellent treatment of cookbook promotion with Jenkinfile. You can never go wrong listening to Noah. He has what I consider to be the best treatment of running Jenkins servers in Docker as opposed to trying to manage it with a chef cookbook. Should you want to manage a Jenkins server with a chef cookbook, though, Stephen King has this Typo 3. All of his infrastructure is up. It's excellent, phenomenal, great starting point. So, taking a step back, what is in the ChefRepo? The succinct version we use is all the unversioned objects in Chef. Cookbooks absolutely have a version. Roles, environments, data bags, they don't. The version that's living in the server is the version that all your clients are going to pull down. So, everything in the ChefRepo is what we call the unversioned object collection. Again, it was roles, environments, data bags. Now, if you want to know what you can manage via the ChefRepo, you can read the Chef API documentation. You can also make a clean directory, copy in your .chef directory, and just do a knife download / and it will give you a ton of things. The roles, environments, and data bags I consider to be the minimum point of entry for what I'd like to manage via Git. But you could, of course, manage cookbooks that way. I will never recommend a mono repo for development. Mono repo where all of your chef policy is in a ChefRepo and you have a cookbook directory with all your cookbooks in it. That is a terrible idea. If anyone tells you I said that, they are lying. But at the root of every ChefRepo, I usually have a Burks file, which is a pointer to all of the cookbooks that that project needs to run with. And as part of these Jenkins pipelines we're going to be talking about, it kicks off a Burks install, Burks upload using this. You could use it in lieu of a supermarket. You could also just have it pointing to entries in your private supermarket or public supermarket. Not as common, but something you could manage via ChefRepo and this Git process is node objects. If you run a knife node show -fj, it will dump out that node as a giant JSON object. If you didn't pass it the long option, it'll give you kind of a shortened version without all the oh-hi. It has the environment, the node name, certain attributes like normal attributes you want to put them in there. It's a thing you can do. You can absolutely capture those objects in Git, and I'll get to that later. You can also do policy files. That's a very common technique. I will tell you that when we did a lot of this work, policy files were not an option. When policy files came around, they had limitations around security teams wanted to do a cross-cutting change across every single machine in the fleet. You would have to regenerate every single policy file. That is no longer true. There's include policy statements that allow you to bring in certain environments or merge two different sets of policy files together. I do worry a little that policy files has gotten rid of the Chef attribute inheritance system and then recreated the Chef attribute inheritance system, but I have it on good authority that they're stopping it too. Also, if you do the knife download / or look at the API documentation, you'll find out that there are ACLs, groups, and users that are objects you could maintain and manage via the API. There's a couple other ones in there, an org list, all the client certificates. Don't manage those. I am not smart enough to do that. You are probably smarter than I am, but that's not the sort of thing I want to manage as part of my policy. Messing with knife ACL commands or trying to change the groups via this might end up super poorly. I don't think you need to do that as part of your day-to-day work. Your mileage may vary. What's my policy on mono repos?
Use them all the time.
Damn it. No, don't do it. Seriously, don't do it. I just saw my note there, wanted to bring that up again. So let's talk about what pipelines are to me. It's anything that's going to act on using source control as a source, let's say, any sort of commit or pull request, and after some validation and testing, it's going to take some actions and promote that to the next higher level of being. That Hedge Ops blog had a very succinct and nice definition that kind of resonated with me because it mirrors the Unix philosophy of one tool that takes an input, has an output, does something well. Don't build a giant thing that does everything kind of. I'm almost always going to talk about Jenkins in this. Nothing precludes you from using another system that knows how to treat branches differently, run different stages of things through different tests, but all my examples are Jenkins files because it's popular. Because Jenkins 2.0 introduced the pipeline plugin, which has a Jenkins file that you can put in every repo. I like the idea of managing the code itself with the automation policy that Jenkins is going to use to promote that. One of these examples had the old style Jenkins where you had a job you had to configure on the Jenkins server, decoupled that from the code itself. That's not as cool. Additionally, pipeline let you dry up your code by taking these 50-line Jenkins files and turning them into a groovy standard library, a pipeline standard lib, and shoving that elsewhere in Jenkins. So each Jenkins files you would have for a cookbook or a ChefRepo would be extremely short, 1 or 2 lines, just saying, do the standard pipeline operation, here are my specific credentials. But the only other thing to think about on pipelines is that every single policy change has to flow through source control. You have to have, Git is all of my examples. There's no reason it could be something else. But that's how your code gets into the Chef server. Furthering that, this is the same advice I give my children. Just put down the knife. Don't use knife. Don't use it for anything. No, not entirely true. A bunch of random administrators running around pushing code up into a Chef server for nodes to download runs about as well as you would expect a bunch of people running around with knives. They get stabbed, they get hurt, people are upset. It's animated. I really mastered this presentation software. So let's talk about why pushing up the policy by hand is bad. There's no easy audit trail. Early versions of the Chef server used to accidentally log instead of the user that made the change, it was the object ID that made the change. They fixed that. Now you can tell that a user made a post command to upload an environment, but you don't know necessarily which environment or what was in that environment. So there's no real clean path for reproducing that. If a bunch of us have run different knife commands and uploaded policy in different orders at different times, you have to coordinate with these people to figure out what happened. You have to look at Slack chat logs, email, that sort of thing. These are all reasons not to push knife commands by hand. It's also really hard to replay that set of changes outside of using the chef server that you pushed your changes to. Later I'm going to get into talking about using AWS to build AMIs and to use Chef Zero without a chef server using the same technique. You can't do that if your only way of pushing policy is to run knife node from file or knife data bag from file, that sort of thing. So the easiest way to make sure that nobody uses the chef server via knife commands is to lock everybody out. This is, of course, overly simplistic. One of the things we like to do is make sure that only the Jenkins user can upload policy to the chef server. That is the only way it gets in. That is the only admin certified user certificate that can push changes to a chef server. However, you want to have the ability to look at the list of cookbooks on the server to run searches against it. So when I have a ChefRepo that controls a chef server, I generally have a .chef directory and a knife that has a copy of a read-only certificate in there. Your security policies may not allow you to have any credentials, even read-only credentials checked into Git. I personally think that if you have access to the source, that's all the stuff that gets pushed up to the chef server, you should have access to look to see the attributes and such on the chef server. Your mileage may vary, but I do like having a read-only certificate that everyone can use to query the chef server, if not push policy. But again, the Jenkins CI user is the only thing that can push policy into your chef server in my world. So let's talk about the first example company. Tiny Corp is not actually its name. That is unfortunate. It would have been a great name. But these are highly anonymized case studies. They were real companies. I blended a couple details to make it less obvious. But I didn't want to use any names, so I can get all specific about them. Super small startup company. There are maybe less than 50 people. I only tell you the number of people so you get a feel for kind of the bureaucratic and organizational overhead that they might have around change control or the number of people they have to communicate with. They have something on the order of 5 people who are actively touching Chef and trying to instantiate policy on nodes via writing cookbooks, changing roles, run lists, etc. They had a software as a service product. It took off, started going well with that. Key, though, is that all the people who were using Chef were good with AWS. They were experts. They were experienced Unix users. They were good communicators. They were all roughly in the same time zone. They were all working pretty close to each other, so they could coordinate very well. And part of being what I consider to be Unix experts is they had the ability to take a chain of events and bisect it and work their way down. They were experienced practitioners. These were not rote operators, which I'll get to later. So let's talk about what the simplest version of a Chef pipeline is. You have a Jenkins file. The Jenkins file does some validation, and it's now time to push the checkout of that ChefRepo up, knife upload slash. That's it. You're done. That, of course, is a gross oversimplification. Knife upload comes in the Chef DK, run knife upload -- help, look carefully at all the flags. What we're doing is we're mapping a single ChefRepo to a single chef org. In this case, we divide it up into prod and non-prod. So we had a prod ChefRepo and a non-prod ChefRepo. We had a prod chef server and a non-prod chef server. Changes you made in one repo would get pushed to that server that it was mapped to. An important thing about knife upload slash is that it is crazy dangerous. There was a sweet bug back in the 12 days where they changed the meaning of a flag or the default for a flag. And if you run knife upload with the purge option, it either deletes all the policy that's on the chef server that isn't in your current working directory, or deletes everything in your current working directory that isn't on the chef server if you did a knife download. At one point, they said something like, well, the chef server repo path defaults to your home directory, and I don't see any directories in there that are on the chef server, and just wipe out someone's home directory. That's probably not going to happen again, but don't run this command by hand. This is not for humans to use. Humans are soft, weak, pitiful. Jenkins will make sure that this works the same time every time. You're going to look at the knife upload slash command. You're going to see that it has an option for don't do roles, do roles, don't do cookbooks, do cookbooks. You can give knife upload / roles / environments / data bags. And like I said, we're initially just going to manage those 3 things because that is enough chef policy coupled with cookbooks and an elaborate cookbook promotion policy to control everything you need about your nodes. Knife upload / isn't the first thing that this Jenkins file runs. Before that, remember I said there's a Burks file at the beginning of the project, and that is a pointer to all of the cookbooks that the project needs to get started. This is not how I necessarily manage every cookbook going into it, but it's going to run a Burks install and a Burks upload. If you have chained your Jenkins job so that the successful promotion of a cookbook then says, oh, and I need to run this ChefRepo promote, that is a way to skip the supermarket and get things into your chef server by pulling off of the master branch of cookbooks. I totally recommend you run a supermarket. It's free, it's cheap, it's easy. But this is a way that cookbooks can get moved into your ChefRepo while you're dealing with it. And again, it's a project-wide Burks file. It's not going to manage every single cookbook, certainly not all the dependencies, and I don't use it to pin versions of cookbooks. I just point it at the head, and I say the head of all these cookbooks is deployable, and I'm going to lock down what each node can consume by using cookbook constraints in the environment. But at least now my environments are managed in this ChefRepo. Let's see. And like I said, I think you're just going to have a couple of cookbooks in there. You're going to have a role cookbook, you're going to have a base cookbook, you're going to have some sort of application-specific cookbook. 3, 4, 5 lines in this Burk file, not 40 lines. Because I did one with 40 lines and it sucks. If you're going to do this and you do the dangerous version of knife upload / then you're going to want to ignore all the policy that you don't want to accidentally manage. So the example code I'll throw up here in a bit, or I'm not going to show you the code, I'll just point you to the repo. Says, hey, I'm never going to let anybody check anything called clients into Git. I'm never going to let you check a PEM into Git. I'm never going to let you check an ACL into Git because I don't want to accidentally manage that, and I don't want Jenkins to blindly Sorcerer's Apprentice wipe out my world with it. All right, so now we're going to talk about an important factor of any pipeline is that it knows how to treat different branches of your repo differently. So the master branch, the way I like to work, and this may not be your cup of tea, is the master branch is always deployable and reflects reality. Whatever is in the master branch of my ChefRepo should be the policy that is on my chef server. Every role in there, every data bag, every environment should match. Since in this case, for Tiny Corp, I'm dealing with a one-to-one mapping of a ChefRepo to a chef org, I can have a bidirectional check. Master, like I said, is always deployed or deployable. Additionally, you configure Git so that the master branch cannot be merged to by any way other than Jenkins running through some tests, validating everything, and then making your changes happen. So that's the master branch. But of course, you have feature and pull request branches. You should not or could not have continuous integration and continuous deployment without tests. I mean, you can, but like bad, right? So these pipelines should do really basic things. Ideally, you're going to customize these to your business needs and things that have burned you in the past, but at the very least, you could, for any proposed feature branch, check basic syntax. Ruby-C all the Ruby files, JSON-lint all the JSON files. You could make sure that everything is formatted properly. You can make sure that all of your all of your environments have equality pins in the cookbook constraints. Any arbitrary business logic you have, you can shove into this validation stage to make sure that nothing makes it to master unless it meets your criteria. Additionally, for every PR that you pull, you're going to run knife inspect. Knife inspect is not included in the Chef DK. It is superior to knife diff in that it can deal with Ruby files as well as JSON files, and the output is super nice. So you propose a PR, Jenkins runs the PR, it checks to make sure that all your files are cool, it checks to make sure your business logic is cool, and then it's going to throw this knife inspect up saying, if you merge this to master, I'm going to make this change to this role, I'm going to make this change to this environment, and then it's on you to say, that's what I wanted, let's merge, or some other reviewer to do that. Since you feel that master is always deployed or deployable, there's nothing stopping you from having that extra belt and suspender check of a separate external process that looks at the master branch of the repo and runs essentially knife inspect against what's on the chef server. If you see that change, then you know someone has gotten a knife and has uploaded policy to your server, and you need to find and stop them. But that's a worthy thing to alert on in my mind. Okay, so make sure I didn't miss any notes here. We're cool. One other thing you can do, and I was a little iffy about including this, you can absolutely take any speculative branch of this repo and launch a Chef Zero server against it and arbitrarily converge some nodes against it. You can copy this ChefRepo policy up to a different Chef server, a throwaway one, and canary nodes in prod, in stage. Anything that makes you feel comfortable about merging this policy change PR branch to master, you can automate, right? It's kind of what we do. So let's talk about other files I might shove into a ChefRepo. So since I included a gem that's not part of the Chef DK, I have a gem file that has knife inspect. If I was running something beyond EC2 Cloud that comes in Chef DK these days, VMware Cloud, or I can't remember any other people's, that's terrible. VMware, that's pretty much my only go-to example. You would include these extra gems that you need as part of your policy. If you had elaborate checks that required external API checks, you would make sure the gem file was there so that your automation process knew I need to load these gems before I can run any of the suites. Similarly, if you have a lot of involved RSpec or other validation tests and you don't want to remember those commands because, again, you're a soft, pitiful human, you would put that logic into a rake file so that all you have to remember is rake validate, rake test. And then, of course, you get to pull that logic out of Groovy, which may not be your primary language, it's not mine, into a rake file so that your Groovy is simplified, the Jenkins file is simplified. Speaking of Jenkins file, you're going to have that to drive all the policy. There's no reason you couldn't use Travis or Circle CI. I'm just using Jenkins because that's what people pay me to do, and I don't go the extra mile to learn something that no one's going to pay me to do. It's not true. It's not true. Yeah. You could include the test suite, like I mentioned. You don't have to use chef spec if you're just dealing with objects in the chef repo. If you want to make assertions about the contents of JSON file, RSpec's a perfectly good language for that. Have a test directory in there. Never upload the test directory, but the test directory says, again, the cookbook constraints always have to be equality pins. I don't have any data bags with the word password in them that are not encrypted. Anything you want to enforce and anything that your company cares about or your process cares about, enforce it via tests, run that on every PR branch and have your Jenkins file or rake file drive it. And I mentioned, of course, you could have launched Kitchen, like I said. If, this is where it gets a little iffy, I think ChefFS lets you deal with Ruby or JSON files if it's building a Chef Zero server. I think Test Kitchen, for whatever reason, only wants to deal with JSON files. If you've made the decision that all of your policy is written down as JSON, of course you could just spin up a Test Kitchen instance and have it point the data bag path and the environment and the role path to this, and then converge arbitrary cookbooks across arbitrary throwaway nodes to prove that your policy is having the effect you want and not laying in wait in the tall grass to ruin your night. Finally, of course, I do include a .chef directory and a knifeRB that points to a read-only PIM. So anybody who has access to this repo can query the chef server. You may not feel comfortable with that. Up to you. I went ahead and wrote a real simple example, and this is what we use to start new clients with. If you turn out to be the 4th, 5th, or 6th follower of @FastRobot on Twitter, I'm going to put all these links up there. So you don't have to take pictures unless you're just trying to get a picture of me. You never know. All right, so that's Tiny Corp. Cool people. Let's talk about Megacorp. Megacorp was a global retail company. They are proudly not a technology company. No judgment. They have on the order of tens of thousands of employees, which I again bring up to point out the bureaucracy and involved nonsense there. They had 500 people-ish committing to Chef, interacting with Chef on a daily basis. I know this because we kept hitting the GitHub enterprise limit. That's a lot of people. They were distributed all over the world. They did not communicate with each other well. They weren't even on the same time zones. They ran what I like to call the Living Computer History Museum. They had critical systems for running on computers. The companies who made them went out of business in the 80s. Nothing ever went away. It was pretty astonishing. All these teams were heavily siloed. They were isolated contract developers. They were, I called them the software abandonment factory because they would put together a small team, they'd write some software, and then they would just chuck it over the wall. Classic. They had change review. We have a policy at our company that we do not speak ill of clients. So periodically, I will just trail off. Look down. No. That's terrible. I apologize. But literally, it was the unethical to DevOps. They just threw things over, and so you had to have a very clear delineation of how you're going to maintain the software and push policy, because you did not have another team that was trying to own what they'd written. They had written something, and now it was somebody else's fault. At some point, they gave like half the ops teams hoodies and said, all right, you're DevOps. But they're just ops folks in hoodies. They had a security, so again, I'm getting into the specific requirements. Now I'm not just bitching, but I'm getting to the specific requirements about what led us to some of these decisions. They had a security team that demanded the ability to make cross-cutting changes across all the machines in their fleet, and didn't want to go through any of the change review process, didn't want to go through any of the testing. This is a problem, we got to make the change now. We were like, that's kind of dangerous. And they were like, they had network interface, or network teams that wanted to leverage all the value of Chef about having Nagios and Cacti monitor their 8,000 network devices, but they didn't want to go through the process or learn cookbooks. So we had to figure out ways to kind of get them into this process without necessarily making them participate in the whole thing. Other things that made us choose one pipeline or another, and things we did to it. They didn't really have the ability to provision VMs that was accessible to end user. Remember, there's 500-ish people who are representing thousands of developers. They needed VMs. The old system was they'd put in a ticket. 3 weeks later, somebody would be like, oh, you forgot to dot the I. And then, another 3 weeks, you get your VM. So we ended up using this Chef-Repo, shoehorning in a multi-cloud provisioning system. And we did this by managing the nodes directory in the Chef-Repo. We literally had a directory called nodes that had JSON objects that were knife node show node name -fj. You take that file down, change the node name, you'd add some normal attributes to say we added an asset tracking and business ownership situation to this. So using normal attributes in this node object, you could tell who owned the machine, which of the clouds it should deploy into, which of the data centers it should go into. Things like the node names ended up telling us whether this was a production machine, a staging machine, or a development machine. It was one giant repo that dealt with every machine in this company's history that was using Chef. This has downsides. I'll get into them in a little bit, but there were some scaling issues with it, and of course the repo itself grew ginormous. But this system did work, and I'll talk a little bit more about where we went with it. Other things that led us to go into this era, open source Chef 11 at the time. This work has been done over the course of many years. So again, there were different approaches we might take now, but you didn't have any role-based access controls. So our general philosophies was to take all of your problems and make them Git's problems. This is a perfectly valid solution if you didn't want to deal with Chef having to create users for Chef, dealing with role-based access control. You have absolute control over who can write to a repo, who can commit to a repo, who can speculatively propose a change to that repo. So make all your problems Git's problems. This also solves the problem I illuminated earlier about access logs, audit logs. If I can have a gigantic Git repo that has every change that has ever happened to any Chef control machine, I can Git log any node, any role, any environment, and tell you who touched it and when. Many a time, I was away from most computers or something else, and somebody would call and say, like, hey, we had a problem with such and such application. I'm like, all right, well, let's just Git log those objects and see who touched them last. We can find that person and see if they were trying to do something in dev, trying to do something in stage. It was all in one repo, so we had a living history of everything. It was kind of cool. Like I said, it solved the audit log issue, because now you had who changed what and when. And if you look at the Jenkins console log that was pushing this, you knew exactly when that change went into production or development or staging. I didn't cover it in this, but remember I said that this is one Chef repo that dealt with multiple targets. Instead of the one-to-one mapping of a Chef repo to a Chef org, I had a Chef repo that knew how to push to 6 different Chef servers, depending on things like the last digit of the node, or whether it was a production, whether it had to be in this city or that city's data center. Now let's talk about the problems with this approach. Well, clearly there's scaling issues. As we got up to hundreds of roles, hundreds of nodes, the knife upload slash started taking longer and longer to run. Eventually, of course, it became intolerable. So the super talented lady, Mugdha Pandit, wrote a small Ruby app that leveraged the Chef DK. And all it would do was when Jenkins fired off, it would look at the commit, the last commit. It would pull the objects out that had been committed in there, map the action. Did the node object get created? Did this role get deleted? Did this environment get modified? And then essentially shell out to the appropriate knife command to run that against the appropriate chef servers, because there are multiple. We started baking more and more logic into this. The node started with a PP, it was pre-prod and went over here, PR, it was prod and went over there. Various development nodes went to other places, that sort of thing. Yeah, so extended that to push to multiple servers, and it was all done in that one application. This scaled to 45,000 nodes by the time I last talked to it. Was putting 45,000 objects in a Git repo a good idea? No. But it worked. And more importantly, we last touched this system in like 2015. Went out for beers with somebody recently, and I was like, you know, is that still working for you? And they're like, oh yeah, we've never touched it. It just keeps on chewing. I don't know what their actual node count is now, but they have absolutely continued to use this system. 500 people of diverse skill levels, some Java developers, somebody else, are happily pushing this, and it's working for them. The monitoring and network teams, we just made them a separate repo that was nothing but their data bags, and all they had to do was manage the data bags, and they had some scripts for, I need to add a new network device. A variation of this job would then push that policy up to the chef server. Cacti, Nagios, whatever, would pull it down and start mapping their targets for them. Again, it's still in use today, and that's pretty cool. I can't give you the code that she wrote because it's super awesome and very specific to the company, but we wrote a very similar one in Ruby. I wouldn't use this. It makes it clear that this is only for example purposes or something to extend, but it's a place to start. All right, I only have 10 minutes left, so we're going to talk about Tech Corp. Third try. It's going to work this time. No, 10,000 person company, again, talking about the bureaucracy, globally distributed, bunch of teams, bunch of opinions on their various workflows. So we're trying to find something that's a common denominator that'll suit a lot of people rather than dictating a policy from the top down that no one would follow. They were a software development company. They're very invested into Jenkins. They do things, they're comfortable with that kind of workflow. They know how to chain Jenkins job because they're already using it to deploy software and things like that and package software. They had a history of using pipeline, standard libraries, tons of example nodes and workers. And they're smart people. They were doing what I consider to be true DevOps. Teams that built the software would run the software. There was none of this thrown over the wall hoping somebody else would do it. I don't have to build for the lowest common denominator. They own their work output and eat their own dog food, as they say. So what we went with was smaller pipelines because we were able to divide the problem up into groups. So since teams were writing their own software and managing their own groups of software, we were able to go back to the knife upload slash technique because we were now dealing with smaller units of policy. As long as you can restrict the policy scope to that team, you now have a small team that's talking about their ChefRepo and their mapping of that ChefRepo to a chef org. You're going to end up with something like 800 different chef orgs because it's a large company and they don't have a lot of reason to cross-communicate. Since we have a CI process for getting policy into that, I don't care if I'm managing 5 chef orgs or 800 chef orgs because it's the same process and it just scales. Again, this lets you get away with knife upload slash because it's that much faster. If you're only dealing with 100 objects, knife upload slash runs quickly. It's because they were comfortable with Groovy, because they had dedicated teams running their Jenkins processes, they could run standard libraries, and any tests you add, any special sauce you put, just move into your pipeline library and your Jenkins file in each ChefRepo stays, again, one line. There were some other considerations. A lot of them didn't want to use a chef server. People who were doing auto-scaling groups didn't want to rely on that chef server being up. So the same output policy when your chef server, when your ChefRepo policy runs, in addition to pushing to a chef server, you can tar up the ChefRepo and treat that as an artifact for an auto-scaling group or an AMI baking to pull down and reuse. They had a policy that higher nodes can't reach down to GitHub to pull code directly from that. So you can, however, create an artifact that is all the policy plus the outputs of a Burke vendor run and things like that. And you can then just replay that into a higher environment. So a pipeline can start the process. The artifact, that ChefRepo tarball, is now the input of another pipeline that replays it into staging or into prod. This is nice because you're re-promoting an artifact as opposed to regenerating that artifact every time and hoping. Yeah, so the trick is, again, Pipeline output is going to create both the policy on a chef server and tarball up that now mono repo. Tricked you. No, it's just, again, don't develop in a mono repo, but all the policy plus a bunch of cookbooks that are specific to those nodes as a mono repo is a perfectly valid distribution lump. I can give that to someone else to replay. That is a deployment artifact. It is not a development technique. Of course, I didn't, oh crap. Well, that went badly. It's fine. Eating into my question time now. So wrapping up. Start with just removing knife access from everybody. You don't get it. You can read from the chef server. You cannot push policy up. Yeah, you're going to have a trusted person or a small team of people who can unwedge things if they get broken or do some emergency fix. But that should be an emergency break glass situation. It should not be the daily operation standard. A simple knife upload from the Knife Essentials utility that are included with ChefDK will get you started. It is only when your scale grows huge or you need to start making complicated logic decisions on what objects go to what endpoint or when that you can have to get away from this. And then just write something that leverages the ChefDK and it'll be fast. We're going to add tests as you get screwed by some policy you promoted. Write a test to make sure that doesn't happen in the future. If you can think of something that you know is going to mess you up, write a test. Check that in the chef validate or in the validation phase when a PR is before it is merged, not as you pushed it up and ruined your day. And then if knife upload starts, wedging on you, think about carving the problem into smaller groups. Does it make sense to have a huge chef server with all of your policy? Or can I say this group of nodes talks over here, this group of nodes talks over there? And if, again, you have to write your own thing, you don't have to shell out to knife commands. You could leverage the API directly. We just weren't good enough at the time. And honestly, shelling out to knife commands is pretty easy. It's just not fast. As you create new use cases, just think about how you can extend what you've got rather than chucking it out and starting over. Run multiple pipelines if you have to. If it's value to you to have interim products that are useful, this is where I push the chef server policy up to the chef server. But I also create a tarball because later I'm going to be baking AMIs with Packer, and all I want to do is grab that tarball down and run Chef Zero as I use the Packer builder, or I'm going to toss that into my auto-scaling launch group configuration. And that is it. We have 3 minutes for questions, or I could perform a small selection of Jesus Christ Superstar. Yes, he asked, can we get these slides from somewhere? They're going to put the deck up. They're going to put the recording of YouTube up as well. But if you look at FastRobot on Twitter, I will put all the links up just one by one. And again, we have 3 followers, so this is just going to be huge for us. Aaron asked, why no mono repo for development? I like to deal with cookbooks as, I'd like to treat each of them as the cookbook that's live, the cookbook I'm developing, the cookbook we're going to talk about developing, the cookbook I needed to go back and make an edit to and push a minor feature out to. When you have a mono repo that is all those cookbooks in one directory in one repo, it is much harder to make a PR that just deals with that small branch. All of your policy can be in that, but each cookbook, I think, should be in its own Git repo. I will die on this hill. We can talk about it forever, but that's my belief. So another question about mono repos versus not. Damn it, people. No. I understand one PR is totally useful if they want to do it. Part of what I'd suggest is every cookbook should have its own CI policy and its own Jenkins job that promotes those cookbooks. Okay. Those cookbooks get dumped into a giant bucket, Artifactory supermarket. Yeah. What actually consumes them is the ChefRepo, the environment cookbook constraints in the ChefRepo, for example, or I shouldn't even tell you this, but you can specify versions of cookbooks in the run list of a role. It's a terrible idea. Yeah, I heard it. That actually might not be a feature. Don't do it, but we did it for a long time. But then you would have one PR that's, hey, all these cookbooks that have been pushed up that are available in the Chef server, now these nodes will consume them.
Yeah, but how about the environments?
Same thing. If your ChefRepo is environments, roles. Now, if you're talking about making cookbooks that act as environments, the environmental cookbook pattern, role cookbook pattern, fine, treat those as their own cookbooks and promote them. And then all you have to do is, hypothetically, the Burks file at the beginning of your ChefRepo points to the latest version of This Is My Whole World cookbook. That's a way to do it. But again, I would actually constrain that in the environment. I want all those cookbooks to live in the ChefRepo, or I'm sorry, in the Chef server, and I want the nodes to only consume what I'm allowing them to consume by using those environmental cookbook constraints. Okay, there's a question is, how are you creating and managing encrypted data bags? Depends heavily on where your nodes are running. My current favorite way to do that is if I'm running on AWS. As I create the ChefRepo, I create a parameter store, copies of the validation certificate and the encrypted data bag secret I made up. And then nodes that run under that control get to pull have access to decrypt those secrets and use them at runtime. Or as I bootstrap the node, I save it to the image that got created. But again, I'm leveraging KMS and SSM inside of AWS. You can get the same effect with Vault. You can get the same effect creating it, but it boils down to there's a secret that got put onto the node when the node was built, and the administrator has the ability to use that secret to encrypt a data bag and put it in. There are way better detailed talks about a survey of all the tools around encrypting data bags and passing secrets. That's just the cheapest, easiest way that I tend to use in the absence of other constraints. Yeah, the only thing that gets put into the repo are the encrypted secrets after they've been the encrypted data bags. Everything else is decrypted on the laptop of the administrator or decrypted on the node that's running it. Never secrets in Git. And if you really want to be sure, write a validation test that's in your CI that proves that that didn't happen. Hey, thanks everybody for coming, but if you don't mind, I'd like to take a picture.